Hi, my name's Emma and I'm currently studying physics with Open University, and my role on the team is project manager. Our university is unique. It's involved in cutting-edge research in space sciences with input into major European Space Agency missions, but it also enables students to retrain and have a second chance in life. Our team comprises of up to 40 students, mostly undergraduate engineering students. Some team members study in Space Science Masters and a couple of PhD students.
Because of the size of the task, and without all the team members being located at the same campus, this has really been a 2-year project rather than the 1-year project we originally imagined. The focus of the team this year has primarily been on coding, with redesign of the robotic arm, comms, and alterations and upgrades to all the other systems. Our rover is robust and very stable, with 35cm diameter wheels, custom made from foam rubber tyres. The rover can tackle a wide variety of terrains and is very stable over large obstacles. The rover has 4 powerful brushless DC motors and 2 large lithium-ion batteries with 30 amp hours of power.
The rover has a modular system, the science module, which will be attached to the rover for the science task. Many teams normally use extruded aluminium for the frame of their rover, but we've taken the step of making the frame functional, and we're actually using the rails for one of the purposes for which they were originally designed. The module uses lead screws and stepper motors in order to accurately measure and action distances travelled by the component parts of the module. First, the sample carousel actuates downwards to move from the stow position to the ground, where the auger then descends to drill, take a sample which will then be placed in a container.
We have carried out extensive research into the region of the Mars Desert Research Station and studied the geology. We also learned about site selection for the rover missions, such as the Open University's contribution to the ESA's X-Mars mission site selection, arguing for the Aram Dorsum site. We had input in this task from OU students involved in the research site selection for the ExoMars rover mission to Mars. This helped us make choices about the task we could carry out, the experiments to prepare, and what to look for in the images of landscape and specific rocks.
The rover will use signals from its LiDAR and 4 cameras to sense and understand its environment. With video recognition, it can detect objects such as rocks and bushes, calculate their distance with the LiDAR, and then navigate safely around them. We have a dedicated user interface where we can enter the target latitude and longitude. Then, in combination with its GPS and digital compass, the rover is able to move autonomously between separate locations. Once the target has been reached, it uses a spiral search pattern to explore the area until, through its video recognition, it locates the tennis ball.
Our robotic arm, although large, is capable of a great deal of dexterity and movement. It has 6 degrees of freedom. A carbon fibre base shaft with a low inertia allows the arm to be moved by stepper motor to any point in 360 degrees. There are 3 limbs on the arm plus the end effector. The limbs are moved by powerful 1500 Newton linear actuators, and then on the 3rd limb is a differential box controlled by stepper motors, giving pitch and roll movements. This allows the arm to use a screwdriver or make finer movements such as tapping on a keyboard. The end effector uses minimal weight in order to reduce the moment, especially at the arm's maximum 1 meter extension. It uses a small stepper motor and carbon fibre jaws. High-density neoprene lining allows the gripper to hold objects and also acts as a ridge with which to lift objects. The prongs at the end allow finer touch to contact objects such as a keyboard and also to hook objects which contain holes.
We are currently on track to raise our target in crowdfunding our project, and this will guarantee that we can also travel to the competition to take part. We're really excited about the chance to represent our university and indeed our country at this fantastic competition.